Okay. It looks like it's working. So I want to talk about the way that Linux store the password. So let me get inside as a root. And we are going to see the file. Password is in the file that is called etc/etc/shadow. So for example, my password, I have a user that is called Eric here. Let's see, where is Eric? Here is Eric. Oh, it's used another, doesn't use the one that I need. Let me see if we have another virtual machine that do it with SHA-256. Otherwise, I will be forced. Let me see here. We did have, that was Debian 11. Let me see here. We have which Debian? I can do. This is Debian 11. So they changed again the way that they store the password. Here we have a Debian 10. It should be still be SHA-512. This is what I want. Let's see this virtual machine. Okay, I'm going to change to be the root user. And let's see the content of the etc shadow file. Yeah, it does use. So look at, this is my username, Eric. This is my password. It is hashed. It is not stored. My password is internet too. It is hashed. So we will see that it is made of 3 parts. So you will have at the beginning $6. That means that we are using the method with SHA-512 bits. Then between the dollar here and the dollar here, you have something that we call the salt. And after the last dollar, we have the password that is encrypted. So there are some tools to generate the password. For example, there is a tool that is called make password. Okay, it's not installed, so I'm going to install it. So before I install something, I do an apt-get update. Okay, then let me search for a tool that is called make passwd. apt cache search. Okay, if I want to install it, I have to install whois. Is it? It comes with whois. Let's see. Make, yeah. So these tools work like that. You type make password, and here you are going to specify with -m the algorithm that you want to use. I want to use SHA-512. For example, I want to encrypt Eric, and let me change the password. Let me create a user and create the password as Eric. So to create a user, we are going to use add user. Let's call this user, for example, John. Okay, the password, I'm going to type Eric. I'm going to type again the password, Eric. The full name, John, for example, Carpenter. Is it correct? Yes. So if I go now in the file, etc shadow, we will have John, the user John, which is there. And this is the password. This is Eric. So you see here between this dollar and this dollar, we have something that we call the salt. I'm going to copy this salt, and I'm going to tell generate the password Eric using this salt. And look at what it generated, the command. Exactly the password that we should have here. So if you look after the dollar, we have 3VTA, and here we have 3VTA MBM, and it ends with FYGB9/FYGB9/. So this is the password Eric with this salt, SALT. So let me explain you how Linux store the password. And we are going to program it. So the hashed password consists in three parts: $6. Then you have the salt. What should I say, salt or salt? What would be the correct pronunciation of that? Salt. Salt. Okay, then you have the salt. Then you have $1, and then you have something that we call the encrypted field. So if I go back to my virtual machine, look at, we have the $6. Then we have the salt between the $2. And after this dollar, we have the encrypted field. So we have three parts. It's very long, as you can see. So the $6 is known as the magic number. And it just tells that the algorithm that we are using to encrypt the password is SHA-512. So there are many algorithms. As you have seen, when I went to the first virtual machine, they were using another algorithm. So to identify the other algorithm, it was starting with $yes, $Y. So $5 will use MD5. Okay, today, normally they use SHA-512. So the password will start with $6, saying that we use SHA-512. Then we have the salt. Between this dollar and this dollar, we have the salt. So the salt can be between 8 and 16 bytes long. Minimum it will be 8, maximum it will be 16. And it will include random character in this range. So it can be a dot, it can be a /, any digit, any capital letter, or any lowercase letter. Let me go back to my virtual machine and see that we have that. So this is where I generated. So this is the salt. between the dollar and the dollar. Let's count the number of bytes. Let's say it have to be between 8 and 16. So there is a T, 1, 2, 3, 4, 5. Maybe I copy it. I don't count it by myself, and I do an echo of that, which is the salt word count -C. There are 16 characters. If you want, you can count them, but there are 16 characters. And as you remember, the character can be a dot, it can be a slash, it can be any digit. For example, here we do have digits. We don't have dot and slash, but we do have digits. Any lowercase letter, as you can see, we do have lowercase letter, and we have uppercase letter. This is called the salt. So what is the purpose of the salt? That you have many ways to encode Eric, and they will be different. For example, another way to encrypt Eric, let me change the salt and put, for example, as the salt 1, 2, 3, 4, 5, 6, 7, 8. Minimum it has to be 8. That will be the salt. So this is another way to encrypt Eric. So as you can see here, we have the magic number, $6. Then we have the salt. I did specify I want to use this salt. The GTD456 it is there. And after the dollar, you have the encrypted field, which have 86 characters. We will see. Always 86 characters. Let me copy it. Let me verify that with you. So I'm going to put it here. Word count -C, 86 character. Okay. So I hear it say the field, encrypted field, is always 86 bytes long. So the salt can vary between 8 and 16 character. So to compute the hash or the encrypted password, there are 3 steps that we have to follow. So we'll have an initialization part to get the initial value. Then we'll use this initial value to go through a loop. And this loop, we will do it 5,000 times. And after the last result of the loop, we will use it to get the hashed password. So here they say to better understand these 3 steps that we have to follow, we are going to encrypt the password Eric with this salt. So this salt, if you count it as 16 characters, it's normal. A salt has to be between 8 and 16 characters. And we want to encrypt Eric. So let's see what we will do. So first, we need to compute 3 parts. We are in the initialization part. Remember, there are 3 parts. The initialization part, the loop, and the finalization part. We are still in the initialization part. And in the initialization part, we need to find part 01, part 02, part 03. So how do we obtain part 01? They say you concatenate the password with the salt. And the resulting string in hexadecimal will be part 01. So the password is Eric. If I put Eric as a string in hexadecimal, it will be that. Do you understand why? What will be 65? Exactly, the ASCII code of the E. What will be 72? The ASCII code of the R. What will be 69? The ASCII code of I. And what will be 63? The ASCII code in C. And this is in hexadecimal. On the salt, we can take any random string. We decided to take this random string that have 16 characters, sorry. So this 41 will be the capital A. This 62 will be the lowercase b, up to this 33 will be the 3. So they say to get part 1, you concatenate the password that you have as an hexadecimal string with the salt that you have as an hexadecimal string. So it will be, as you can see here, the password and the salt. So it's a long algorithm, and I want to program it with you. So every time that there is a step, we are going to program it. So let me go back to my virtual machine, and we are going to work on that. So let me go back and be a normal user. I'm going to go on the desktop and create a file that is called, for example, hashed password. Hashed password dot bash. We are going to do a bash script. So I'm going to put the shebang here. Okay. Let me make this file executable. So change mode user plus execute. The file is called hashed. Here I'm Eric, and here where I am. Oh, I created it on the desktop. So let me go in the desktop, change mode, user plus execute, hashed password. So let me just verify that the bash is where I pretend it's in this machine. It is in user bin bash. So let me put here the path user bin bash. Okay. So when I use this command, I want to use this command this way. So we are going to specify the name of the command, follow it by the password, follow it by the salt. So the salt in this case is this. Let me copy it. It's any random string with the characteristic that we say, no? With this salt. So we will run it like that. So one of the first things that I have to check that the person specified the password and the salt that the person wants to use to get the hashed password. So I'm going to do an if here. If the number of parameter is not equal to 2, then I'm going to guide the user on how to use the command. So I'm going to echo usage, how you have to use this command. And I want this not in the standard output, but in the standard error. Then I'm going to echo how to use it. So the name of the command per se, so the password that you want to hash, and the salt that you decided to use. Let me exit here with 1 because there were a problem. And here, let me exit with 0. Okay, so let's see that if I don't put the here, it didn't show any message. If I put more parameters, it have to show a message. It did show a message. If I put less parameter, for example, I put the salt, but I don't do the password that I want to hash, it shows me a message. Okay, so it's working fine for now. So we already saw that we need to compute part 01. So what can I say about the password? The password will be in $1, no? And what can I say about the salt? The salt will be in $2. So I prefer to use password and salt than $1 and $2. Okay, so first, I want to check that the salt is correct. So will this work if I type this? Will this work? Yes or no? And if it doesn't work, why it doesn't work?
It's not going to work because it's not at least 8 characters.
Exactly. The salt have to be at least 8 characters and at most 16 characters. So if the person don't specify the number of characters, the correct number of characters, I should tell the person there is a problem with the salt. So another thing, should, for example, this work? Like this one, should it work? No, because there is too much, okay? Here we have more than 16. So let me try another one. What about this one? Should this one work? This one has 15. If you count them, there are 15 characters. So it should work. But I have to verify that the salt only have dot, / digit, capital letter, and lowercase letter. Now, if I do that, should not work. Why? Because this character is not authorized in the salt. We cannot have a plus. Okay, in the salt we can only have dot, / digit, capital letter, and lowercase letter. So I want to check that. I want to check if the salt have a problem because it's too small, too long, or it uses letter, or it uses characters that are not allowed. I want to tell the user there is a problem with the salt. So I want an if statement here. So if there is a problem with the salt, so I'm going to echo the salt and verify with a grep command that it have what it is expected to have. So you know the grep command, no? So for example, look at. So this will not be a correct salt. Why? Because it's too short. So in the grep command, I'm going to say, okay, this is to say the beginning of the string. So you will find the beginning of the string. Then you should find either a dot or a / or a digit. So it's a range 0-9 or a capital letter. It's a range capital A - capital Z, or a lowercase letter. It's a range lowercase a - lowercase z. So you will find a character, but this character can be between 8 and 16 times. So the way to say that is you say the minimum value, the minimum number of times that this character can be is 8 times up to 16 times. Then you will find the end of the string. So if this string comply, it will show me the string. It didn't show me the string, as you can see. Why? Because the string is too short. So it has 4 characters. Let's put 5, 6, 7. Now it has 7 characters. What do you think? Should it, when I execute this command, should it show me the string? No, because it don't have enough characters. So let me hit enter. It doesn't show me the string. Let me put one more character, for example, a dot. Now it has 8 characters, and they are all correct. It should show me the string. It should echo the string. It did echo the string, saying, yes, this one works. It has what you want. So I'm going to put, for example, we have 8 characters, 9, 10, 11, 12, 13, 14, 15. This one should work. Okay? It have 15 characters, and it do have the characters that are allowed. So let's see. It did echo it. So if I put one more character that is legal, it should work. Let me put an E. So this one should work because it has 16 characters. It did work. Now let me put another one. Now we have 17. This one should not be echoed because it's too big. You see, it was not echoed by the grep command. Okay, so maximum, minimum 8, maximum 16. Now let's put a character that is not allowed. For example, I put a plus. It should not echo it. You see, it did not echo it because there is a character that is not allowed. Or let me put another character that is not a LOID. For example, a dash. A dash is not a LOID. It does not echo it. Okay? But if you remove the dash, it will echo it. So only dot, / digit, capital letter, lowercase letter. So look at this expression. I'm going to put it here. So I'm going to use the option quiet, which means that don't echo the string. I will work on the return statement. So I will say what we just saw, no? We will have the beginning of the string. Then we will have a character that can be a dot or a slash or a digit or a capital letter or a lowercase letter. And this, if I do, for example, that, I'm saying it's have to be exactly 8 times. Now, if I put, which is curly brace, 8 curly brace, I have to escape the curly brace. Now, if I put 8,16, so this character, the character that is before the number of times that I want it, which is either a dot or a slash or a digit or a capital letter or a lowercase letter, have to be between 8 and 16 times before you find the end of the string. So the dollar is the end of the string and the caret is the beginning of the string. So I'm going to do that, semicolon, then. So if there is a problem, I'm going to show the user there is a problem with the salt. So echo, let's just put problem with the salt. And we are going to show the salt that create the problem. It is in $salt. I want that in the standard error. And I want to exit this time with a different error code. So previously I exit with 1, this time I'm going to exit with 2. So let's see if my command still works. Okay, it is there. Here, it didn't show problem with the salt. Look at what I'm going to do, for example. This is already 16 character. If I add a 0 here, it will be 17. So it have to tell me problem with the salt. You see, problem with the salt, it show me the salt. The salt is too long. For example, this one will be too short. So it have to tell me problem with the salt. Okay? So let's put 8. So now it should not show me any problem. If I put a dot, we have 9 characters. It should not show me any problem. If I put a /, it has 10 characters. Those characters are a LOID, so it should not it should not say that there is a problem with the salt. Now let's put a dash. A dash is not a LOID in the salt, so it should tell me there is a problem with the salt. And as you can see, it tells me there is a problem with the salt. Okay, so I did check that the salt is between 8 and 16 characters long, and it should only have dot, / digit, capital letter, and lowercase letter. Okay, so let's compute part 1. So if you remember, part 01 is what? Is the concatenation, let me show you again, is the concatenation, they say here, of the password and the salt. And we want the result as an hexadecimal string. So I'm going to concatenate the password and the salt. So I want the password. When you do the concatenation, look at the slides. You need to convert the password as an hexadecimal string and the salt as an hexadecimal string. Then you concatenate both. You see in blue here is the password, and in red here is the salt. But both of them are like an hexadecimal string. So I'm going to do that. I want to concatenate the password with the salt. And let's echo the result to see that we are doing fine. So is this okay for part 1? In this case, it's going to concatenate Eric with the salt, but we will not have an hexadecimal string, no? We want the result as an hexadecimal string. We want that. We don't want Eric, A, B, H, A, D, E. We don't want that. We want that. So if I run it up to now, I will have this, which is Eric and the salt as it is that are concatenated. So let me run it. Let me run it. So look, we have exactly what I tell you. We have the password and the salt that are concatenated, but I want them in hexadecimal. What can I do over part 1 to have them as a hexadecimal string? What can I do here? How do you convert, for example, Eric in hexadecimal as an hexadecimal string? Let's convert, for example, ABC. So A is for 1, B is for 2, C is for 3. So what command will show me for 1, for 2, for 3? Here, I can do XXD dash P. Look at it, for 1, for 2, for 3. Okay? It's a way to convert a string into the hexadecimal string equivalent. So here, what I can do, I can say I want to execute a command, and this command will be echo-n $part01, and I will send that to xxd-p for postscript. So show it without other details. Look, if I don't do the postscript, it will show me, for example, the address. I don't want the address. And that for 1 is A, for 2 is B, and for 3 is C. I don't want that, so I have to put the -p postscript, just show it as it is. So let me again run my command, and look what we have now. We have the password here, and then we have the salt in hexadecimal. Okay, so we already have part 1. So let's continue. Now, the slides say need to compute part 2. So let's say that the length of part 2 have to be the length of the password. So my password is Eric. The length of Eric is 4 characters. So the length of part 2 will be 4 characters. Okay? So first, to compute part 2, they ask you to compute something that is called alternate. An alternate will be the SHA-502 hash of the concatenation of the password, the salt, and the password. So look at here. Alternate is the SHA-512 of the concatenation of the password, the salt, and the password. Okay? So we are going to do that. I'm going to do the concatenation of the 3, and I'm going to take the SHA-512. So let me continue here. I need to compute part 2. No, I need to compute alternate. First, we need to compute alternate. So alternate is the concatenation of the password, the salt, and the password. And then what else we have to do to compute alternate? We have to compute the SHA-512 of this string. So I'm going to do here echo-n, and I'm going to send it to SHA-512 soon. By the way, before we program it, we could, for example, do it here, no? So let me define a variable that is called password. I'm going to put Eric inside. Let me define another variable that is called salt, and I'm going to put the salt inside. So let's compute the alternate. So alternate will be the concatenation of the password with the salt with the password. So if I look the content of alternate, I should have Eric at the beginning, I should have the salt in between, and I should have Eric again. So it does work. So then over that, what should we do? We need to compute the SHA-512. So I'm going to do echo-n alternate, so we don't have the enter, and I want to compute the SHA-512 sum. Look at the result. It starts with 3, 4, blah, 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 blah. So this is the SHA-512. You can see that the command SHA-512 put a dash at the end. I don't want this dash at the end. So what can I say? Here we have two fields. The first field is the SHA-512, and then we have a second field that is a dash. I want to remove the second field. So how do you remove the second field and keep just the first column? You can use AWK and say just print $1, which is the first column. I forgot to put curly brace here and curly brace here. The command that I want to execute have to be in between curly brace. So look, we have this. So they say this is alternate. Okay, let me show you back. We can compare what I just compute. Let's see if we have some space here and compare. Look at alternate start 3, 4, A5, F0. Look at them here. 3, 4, A5, F0, and end with, for example, B5, 70, 74. Let's see the slice, and end with B5, 70, 74. So look at in the slice, since it's long, I break it in 4 pieces. Okay, here in the computer, don't break it in 4 pieces. It put it all the data, but in the slides, of course, for presentation, I break it in 4 pieces. So this is alternate. So we already know how to compute alternate. So now let's do that at the level of the program. So I will do at the end AWK, and inside curly braces, I'm going to put print $1. Just show me the first field. And to verify that everything is working fine, let's echo alternate to see that we compute it correctly. So let me execute my program, and I should see that appear in the screen, which is alternate. So, okay, it is there. Okay, so it's the same string as you can see, no? So my program compute alternate without problem. Okay, let's continue. After that we have computed alternate, oh, by the way, they say that to compute part 2 will be some part of alternate. And they say that part 2 have to have the same length as the password. So the password is Eric. Eric has 4 characters. So to build part 2, I'm going to take the first 4 characters of alternate. So this is 1 character. This is the ASCII code in hexadecimal, no? 2 character, 3 character, 4 character. So it should be 3, 4, A5, F0, E4. So let me program that also. Here, how can I say that from alternate, I just need the first, well, it will depend on the password. If the password has length 4, I want the first 4 character. How can I say that? I want to put that in part 2. In part 02. So what do you think we can do? Let's try it here. We have the variable that is called alternate. Alternate now is this. So alternate is this. Let me see. Okay, we have alternate. And I want the first 4 character. 4 because the length of Eric is 4. 1, 2, 3, 4. I want those. How can I extract the first 4 character? We do have a variable that is called password, no? So we can compute the length of the password. How can we compute the length of the password? This will be the length, 4. So this is command that you can type to get the length. You use word count -c is for character, count the number of character. So there are 4 characters in Eric. Okay, so now I want in part 2, part 02, I want the character that should go. So what formula can I put here? So we can echo alternate and say that we want some. Before I do that, let me show you how we can get. Let's say that I have a string. Let's put Jacksonville. How do I get from this string, for example, the first 4 characters? What can I do here to get the first 4 characters? I want Jack. So you can use the cut command with the option -c. I want from column 1 to column 4. Look, it gives me Jack. If I want son, how can I have son from Jacksonville? So J is the first character, A is the second character, C is the third character, K is the 4th character, S is the 5th character. So I want from the 5th character to character 7. It's giving me son. So you see, we can cut part of the string. So I want to cut this. I want to have that. In alternate, we have a very big string. I want this. The first character and the number of characters is length of the password. So what formula can I write? Part 02 is what? What instruction can we write? We can echo alternate. And then do what? With alternate. We can cut it. -c, I want to start in 1. And how many I want? So since Eric have 4 characters, here I have to put 2 times the length of Eric to have the first 4 characters, no? So let's see. If I echo part 02, it does have what I need. But of course, I cannot write 8 here. I need to write something that depends on password. I have a variable that is called password. So I need to do, instead of 8, I need to do length of password times 2. So how can we do that? I'm going to execute a command here for the second for the range. From 1 to, I execute a command, and the result of this command will be, in this case, it has to be 8. So I need to do 2 times the length of the password. So let me first do the length of the password. How can I do the length of the password? I can type echo -n $password pipe word count -c. So this will show me this, because I am not multiplied by 2. So if I tell what is in echo, I just have half of it. I need now to multiply the length by 2. So in this one, we say 1 to 4. I need to do 1 to 2 times 4. So what can I do? I can execute another command. For example, the command expr. So this will be 4 times 2. Look at. So this is the formula that I need. Okay? So here we are going to put this formula. We already have alternate. So we are going to say echo -n alternate. This you are going to pass it at cut with the option I want a range of columns starting in column 1 up to a certain column. So this column should be 8 in my case, but I cannot write 8 here, because if the password don't have 4 characters, it will not be 8. So it have to be something that depends on password. So first, let's put, for example, length of password. How do I compute the length of the password? I can echo the password and send it to word count -c. Count the number of characters. So this will give me the range 1-4. So I need to take this result and further process it. I need, for example, to use the expr command, where we have 4 times 2. Okay, I think it's okay. We don't have problem. And I can echo $part02. Let's see if it's work. Let me put it a little larger so we can see it all. Okay, let's execute the command. There is a problem. There is a missing parenthesis, so they are not balanced. 1, 2, 3. So I close the counting. Yeah, there is a missing parenthesis here. That's true. Let's do it again. Okay, this is part 2. Okay, which is 34 A5 F0 E4. So here they give it to you. So I'm going, well, let's continue reading what we have to do. We need to compute part 3. So let's see how we compute part 3. So they say here to compute part 3, this is part 2. We already did it. Okay. So parse the password length from right to left, bit by bit, stopping after the most significant 1 bit. So look at, the length of the password is 4. See, if I write that in binary, it's 100. They ask me to parse the length from right to left. So first I'm going to have a 0. Then I'm going to have a 0. Then I'm going to have a 1, and I have to stop here, because they say parse the length from right to left until you reach the last one. Okay, I'm done. I will pass 3 times in this case. Okay, so they say, so start with part 03 as an empty string. And for each one that you encounter, append at the end of part 3 alternate that we just compute. And for each 0 that we encounter, append at the end of part 3 password. So look, if I parse, the first thing that I find is a 0. Since I found a 0, I have to append password. Then I continue. There is another 0. I have to append password. Then I continue. There is a 1. When there is a 1, I append alternate. And since there is no other value, this is the last one, I stop it here. So if it's a 0, I append to part 3 the password. If it's a 1, I append alternate. Okay? And we have to start with part 3, which is empty. So look at the result of part 3. The result of part 3 will have the password as an hexadecimal string, which is Eric, the password, and the alternate. So the alternate is long to write. Look at what I'm doing when it's long to write. I write the beginning part and the ending part. No, this is what we saw here. No, here it's really, this is alternate. I show it in 4 rows, but really I should not show it in 4 rows. And to say that it's long, I put some of the digit at the beginning and ... and some of the digit at the end. To say that it's very long, and I don't want to write all of them. It's too long. Okay, so let's do that. So help me here. So let's compute first the length of the password. How can I compute the length of the password? Let's call it length pass, or pass length. Let's call it pass length, password length, pass length. How can I compute the length of the password? So I need to execute which command? Echo -n $password. And this I'm going to send it to wordcount -c. So that will be the length of the password. By the way, I don't need to show part 2. I know that part 2 is well calculated already. Okay, so they say parse the length of the password from right to left. And if you find a 0, concatenate to part 03 the password. And if you find a 1, concatenate to part 03 the alternate that we just computed. No, we just computed alternate here. So in case that we find a 1, we will put alternate. So what should I do here? I can do a while loop. While what? While the password length is not 0. What should I do? Do done. What should I do every time that I pass? Oh, by the way, before I start passing, I need to define part 03 as an empty string. So I will say, if the less significant bit is a 0, I'm going to concatenate to part 3 the password. So how can I say if the less significant bit is a 0? If, okay, there is a powerful way, which is parentheses, parentheses, and parentheses, parentheses. It used the syntax of C and C++. So I want to say if the less significant bit of password length. So it will be password length modulus 2. This is the less significant bit. So if it is 0, what should I do if it is 0? So if it is 0, we are going to concatenate at the end of part 03, we are going to concatenate password. So what should I write here? Part 03, How do I concatenate at the end of part 03? The password. So I will say, I will replace part 03 with the actual content of part 03, concatenated with the password. So of course, if I write password like that, it will not work because it will be the password like Eric. I don't want Eric, I want the hexadecimal string that corresponds to Eric. So what should I do here to say, oh, I want the hexadecimal string that corresponds to Eric? What should I do here? I'm going to echo this, the password, and I'm going to send it to xxd-p. It will convert a string to the hexadecimal string representation. Okay, it does concatenate. Okay, now, if it's not a 0, it means it's a 1. If it's a 1, what should we do? We should concatenate at the end of part 3. We should concatenate alternate that we compute here. But alternate is already in a hexadecimal string, so I don't need to convert it. I'm just going to put alternate here. And of course, I need to update my password length. So password length will be what? Will be the password length that I have in this moment divided by 2, which means I am removing the least significant bit. And at the end, I can echo what I have in part 03 to see if it's work. Okay, so let's see. Since 4 is 100, we need to do password concatenated with password concatenated with alternate. So we already have alternate. So we need to do password concatenated with password concatenated with alternate. So how do I do that? I need here password, but I need it as an hexadecimal string, so xxd-p. And I need it a second time. So echo-n $password, and I'm going to send it to xxd-p. So look at the result. This is the result. So this is Eric. This is Eric a second time. And this is the alternate. So we should have that when I run my command. Let's see if we have that. We run the command. So there is some problem in line 26. Let me see. Line 26. Oh, we don't need a $sign, sorry. Okay, that's true. Let me execute it again. Okay, look at this that we are expecting and what I just got. It's exactly the same thing. So here we have Eric. Then we have Eric. And then we have alternate. Alternate starting 3, 4, A5 up to the end. So it's good. We are computing part 3 correctly. And of course, here they give us the result. So you see, we have Eric, and then we have alternate. So now we computed part 1, part 2, and part 3 with success. So let's see what is the next step. We need to compute the initial value. After the initial value, we have finished with the initial part. We will go to the loop. So remember, there is an initial part, there is a loop that we will do 5,000 times, and then there is a final part. So now we need to go and compute the initial value. So they say to compute the initial value, it will be the SHA-512 of the concatenation of part 1, part 2, and part 3. So as you can see, it is there. You do the SHA-512 of the concatenation of part 1, part 2, and part 3, and you should get this result. So it should start with 262D. So let's verify that. Let's put here that we want to compute the initial value. So init value is equal to the concatenation of part 1, part 2, and part 3. So I'm going to put part 01, follow it by part 02, follow it by part 03. So of course with $, I want the content of part 01, I want the content of part 02, and I want the content of part 03. And then what should we do? We compute the SHA-512 of that. So I can just do, for example, here, echo -n of this, send it to SHA-512 sum, and send it to AWK to remove the final dash. No, you remember there is a final dash. I'm going to select the first column. And let me echo init value to see if it is correct. Oh, before I do that, I need, this is a hexadecimal string. I need to convert this hexadecimal string to the correct string, first to a string. So I'm going to use XXD reverse postscript. Okay, with that, we should have the initial value. So let me run the command to see. Okay, the initial value is here because I'm still showing part 3. Let me remove show part 3. I just want to focus on initial value. Let me execute it again. So this is the initial value. It starts in 262D73. Look at 262D73 and end with 2721B8 and end with 2721B8. Okay, we did compute correctly the initial value. So now we are going to go to a loop. Let's see. Oh, we need to compute the p byte and the s byte. I forgot that. So we still have to go a little more. So how we compute the p byte? The p byte, they are called p bytes because we are going to get them from the password. And there is another slide after where we compute the s byte. They are called the s bytes because we get them from the salt. So how do we compute the p byte? So first of all, they say that the length of the p byte string shall be the number of characters in password. So Eric has 4 characters, the length of p byte will be 4 characters. Remember, 4 characters mean that if I show p byte as an hexadecimal string, I will have 8 hexadecimal digits, no? Okay, so they say start with an empty p byte string. Then for each character of the password, concatenate password in p byte. So look at, then replace the compute the SHA-512 of a p byte to obtain the resulting p byte. So look, the password is Eric. The length of the password is 4. So I need to concatenate 4 times Eric. Eric. Here we concatenate 4 times Eric. I need to compute the SHA-512. It will give me that. And since they say at the beginning that the length of the p byte string must be the same as the length of password, I'm just going to take from this result, I'm just going to take the first 4 bytes. So the 9E is the first byte, 44 is the second byte, 49 is the third byte, and 0A is the fourth byte. So the p byte will be like that. Okay? So let's see if we type the code for that. So we need to create okay, the initial value, I already know that it worked, so I'm not going to visualize it anymore. So I need to compute the p byte. You remember how we compute the p byte? We start with an empty string. And for each character in the password, we are going to concatenate the password at the end of p byte. So how many times I need to do it? I need a for loop, no? Because I need to do that several times. So I can do a for loop and use the C++ syntax. When you use the C++ syntax, you need to put 2-time parentheses. So I need to do that how many times? Before we go there, maybe we compute again the password length. We have the formula here. Let me put it. So I will start in 0. I will be less than the password length. I will increment I by 1. This is C++ syntax. Do, done. Between do and done, we put what we want to repeat. So what do we want to do? We want to update p byte. So we concatenate at the end of p byte the password. So $p byte, $password. So like that, we'll create Eric, 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 Eric 4 times because the password are 4 characters. Now, we need to compute the SHA-512 of the result. Okay, so let's replace p byte. I need the SHA-512. So I'm going to do is equal echo-n $p byte, password byte. Those are the bytes that are derived from the password. I will call the SHA-256 sum. And since it's going to put a dash at the end, I'm going to remove the dash with AWK. And between curly brace, I'm going to say I want just the first column of the result. Okay, so I already passed the resulting string to, oh, by the way, it's not 266, it's 512. Okay? Okay, so what should I do here? Now I need to say if I show the result, p byte, the byte associated with the password, it will be too long because I forgot to trunc it. So let's see, let me execute that and let's see the result. So here is the result. And let's see. Why we have to, oh, okay, I see. So what we just compute here, let me put it here. Look at 9E4449, 9E4449. We do have it, and it ends with 08. It ends with A0, 8109, A0, 8109. It's correct, but we just need the very first byte, which is the first 4 bytes. First byte, second byte, third byte, 4 bytes. We just need these 4. So let's do the same thing that we did previously and cut the string to have only, it's not 4, it's the length of the password, because this string has to be the length of the password. So what should I do here? I can change p byte with what? So I'm going to echo p byte, the password byte, and I'm going to cut them. Cut dash e for columns from 1 to, I need to say 1 to 8, which is 2 times 4. The same problem as previously. So we are going to replace here. Let's do for now for 1 to 4. 1 to 4 will be echo password and count with word count the number of characters. Okay, so this will do 1 to 4. I don't want 1 to 4. I want 1 to 2 times 4. So again, expr of this result time, I need to escape the time, 2, I close the expr, I close this one, no, that start here. Okay, so it should be fine. Let me just show that at the end. Now it should show what I need. Let's see, I'm going to execute it, and look, we have 1, 2, 3, 4. And this is the first 4 bytes here, 1, 2, 3, 4. Bingo, we have the p byte that we get from the password. Now we need the s byte that we are going to get from the salt. So look at the formula to get the s byte. So they say that the final length of the s byte shall be the number of characters that we have installed. So how many characters we have installed? 16. So the final string have to be 16. If you look, 1 byte, 2 byte, 3 byte, blah, 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 up to 16. So this will be byte 16. This is what we want at the end. So how do we get there? So first, we start with the s byte. It's called s byte because we get this byte from the salt. So we start with an empty string for s byte. Then look at 16 plus the first byte of initial value. So look at initial value, it is there. The first byte of initial value for us is 26 in hexadecimal. 26 in hexadecimal is what? In decimal. 2 times 16, which is 32. 32 plus 2, 32 plus 6, sorry, will be 38. So look at, they say here, the first byte of initial value is 26 in base 16. It will be 38 in decimal. So this is 38. So 16 plus 38 is what? 54. So what I need to do, I need to concatenate the salt 54 times. And then it's what we are seeing here. We are going to concatenate the salt 54 times, then take the SHA-512. So let's implement that. So remember that the number of times that we are going to concatenate the salt with itself is 16 plus the first byte of initial value. Okay, so I want to show, for example, here this 54 before I proceed, which will be the length, the number of times that we have to concatenate. So how can I show this 64? So I need the first byte of initial value. So how do I get the first byte of initial value? I can do echo -n init value, it is called, and then we need to cut from 1 to 2. Well, this will be what? an hexadecimal value. Now I need to convert this hexadecimal value into what? Into a decimal value before I can add 16. So look what we can do. We can do, for example, print f. I'm going to print a decimal value. And this decimal value is going to be what? I need to convert this guy from hexadecimal to decimal. So if here I put 0x, will it work? So remember, it's 26. 26 is 2 times 16, which is 32 plus 6. It should be 48. Okay, there is a problem here. We have to solve it first. Yeah, dollar is missing. Let's try again. Parentheses here, parentheses here. Show in decimal. 1, 2. It's a percent D here. Okay. Invalid X number now. Oh, I got dollar initial value. I want the content of initial value. Okay, we have the 38. 38 plus, we need to do 38 plus 16. Remember that 38 is 2 times 16, which is 32 plus 6, no? Because the string starts with 2, 6. Okay, we already have one part. What else we need to do? So let's call it num iteration. Num iterations equal this. And we have to add up 16 to that. So we can do num iterations equal what? So dollar what? How can I add 16 to num iteration? I can just do parenthesis, parenthesis, which is going to use the syntax of C++. So num iteration plus 16. And we are going to show the result. So echo, I don't need this anymore. Let's show num iteration. And here we need 54. It has to be 54. Let's see. Didn't work. So num iteration, the word R. Do it. 54. Okay, now that we have this 54, we can do the S byte. So the S byte will be what? I start with an empty S byte string, and then I do a for loop. So I will start in 0, and I will loop for num iteration. Num iteration. I'm going to increment I, do, done. Okay, so what should I do here? Update numByte. And how I'm going to update numByte? I'm going to concatenate to the actual value, update sByte. I'm going to concatenate to sByte, what? The salt, no? Okay. Then I need to compute. Let me just copy this one and change it. The SHA-512. So instead of pByte, it will be sByte. This will compute the SHA-512. Let me just echo it for now to see that it is correct. And then we will cut it to have the correct number of bytes in the sByte, no? Okay, let's see if it's work. So let's see if this result is the one that they have here. Yeah, it's the same one. I can see it already. So look, here we have at the beginning 58 BB C6, 58 BB C6, blah, 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 up to the last 3 bytes are 285581. Oh, by the way, they are not the same. Let me see. Oh no, the last are here. 1, 2, 3. They are E23324. E23324. Now we have to concatenate. We just want some of them. So the number that we want is the same as the length of the string salt. So what should we do here? Let me just copy this and change it because we already did it. So the sByte is going to be, I echo the sByte and I cut. It's not with the password, it's with the salt. And I think this is all I need to do. And it should get me the portion that I need. So let's see if this is the portion that I need. So look at, it starts with 58 BB C6, 58 BB C6, and end with 285581, 285581. Okay, so I could compute without problem the pByte that I get from the password and the sByte that I get from the salt. So now there is a loop. So let me go back. I stay here. There is an initialization part, we just end it. The initialization part successfully. Now there is a loop part. We are going to go to the loop part. Let's try to understand how the loop works. So look, here they explain the loop. We have to loop 5,000 times. We need to do a for where I vary from 0 inclusive to 4,999 times. Okay, so we are going to, every time in the for loop, we are going to compute a new SHA-512 hash. And it will base it on the one that we compute in the previous iteration. To start the iteration, we will have a value that is called intermediate. And this value intermediate, we are going to initialize it with the initial value that we compute in the first part. So we just compute an initial value. It is there. So this will be the initial value of intermediate. So look, every time that I will execute the for loop, I will check all this if independently. So let's say the first time I is 0. So here we have a first possibility. So if I is 0, should I take into account intermediate, yes or no? So look at I is 0. When 0 is even. Is 0 even? Yes or no? Yes. So we are going to take into account intermediate. So let's continue. If I is odd, is 0 odd? No. So we are not going to take into account the p-byte string. Let's continue. If 0 not divisible by 3, 0 is divisible by 3. Okay? So we are not going to take into account the s byte. Now let's continue. If 0 is not divisible by 7, 0 is divisible by 7. So we are not going to take into account the p byte. Let's continue. If 0 is even, 0 is even. So we are going to take into account the p byte. So we did take into account intermediate, and now we are taking into account the p byte. And let's continue. 0 is odd? No. So for the first iteration, we took into account intermediate and the p byte. So look, here they say, for iteration 0, you take into account intermediate and the p byte. Let's see iteration 1. Let's run this with 1. 1 is even, yes or no? No. So we don't take into account intermediate. 1 is odd, yes or no? Yes. So we take into account the p byte. Look at here. We take into account the p byte. You see? Okay, let's continue. If 1 is not divisible by 3, this is true or false? Can you divide 1 by 3? No. You can divide 3 by 3. You can divide 6 by 3. You can divide 9 by 3. But you cannot divide 1 by 3. You cannot divide 2 by 3. You cannot divide 4 by 3, 5 by 3. So 1 is not divisible by 3. So we have to take into account the s byte. Look at the second that we take into account, the s byte. Let's keep going. Can we divide 1 is not divisible by 7? This is true or false? This is true. So we have to take into account the p byte. Look at here. We take into account the p byte. Let's keep going. 1 is even. False. 1 is odd. True. So we have to take into account intermediate. We take into account intermediate. You see how it works? Iteration 2. Let's put 2 here and see which one we have to take into account. So according, we have to take into account intermediate, S bit, P byte, and P byte. Let's see if it's true. So if I put 2, 2 is even, yes or no? Yes. So I need to take into account intermediate. So look at it here. I take into account intermediate. Now I go there. 2 is odd, yes or no? No. So I'm not going to take into account the p byte, okay? I go here. 2 is not divisible by 3. This is true or false? This is true. You cannot divide 2 by 3. So I have to take into account the s byte. Look at the following that we take into account the s byte. Now I come here. 2 cannot be divided by 7. This is true or false? This is true. So we take into account the p byte. Look at, we take into account the p byte. I continue. 2 is even. True or false? True. So I take into account the p byte. Look at it here. I take into account the p byte. Now last. 2 is odd. It's not the case. So I don't take into account intermediate. You understand how it's work? Let's do iteration 3. So it's always the same thing. We have to pass with I is equal to 3 all these 7 possibilities. 1, 2, 3, 4, 5, all these 6 possibilities, sorry. So let's see. 3 is even. True or false? False. So I don't take into account intermediate. As you can see, we don't start with intermediate here. Now I say 3 is odd. True or false? True. So I take into account p byte. It is there. I take into account p byte. Now let's go here to the third condition. True is not divisible by 3. This is false. Since it's false, I don't take into account the s byte. Here, let's see. I cannot divide 3 by 7. This is true. So I take into account the p byte. It is there. Let's continue. 3 is even. False. I don't take into account the p byte. There is a last condition, which is condition 6. 3 is odd. This is true. I take into account intermediate. It is there. You understand how it works? Let's do 4. So 4 is even, yes or no? Yes. So I take into account intermediate. It is there. Then 4 is odd. This is not true. So I don't take into account the p bytes. Then 4 cannot be divided by 3. This is true. I cannot divide 4 by 3. I can divide 3 by 3, 6 by 3, 9 by 3, but I cannot divide 4 by 3. So since it is true, I have to take into account the s byte. It is there. Then 3 cannot be divided by 7. This is true. So I have to take into account the p byte. I take into account the p byte. Then we do 3 is even. This is false, so I don't take into account the p byte. And here 3 is odd. This is true. I'm doing 3 and I'm in the line of 4. I was doing 3 or 4. I was doing 4. So 4 is even. Let's do 4 again. So 4 is even. True, I take into account intermediate. Good. So 4 is odd. That's not true. So I'm not going to take into account the p byte. 4 cannot be divided by 3. This is true. So I take into account the s byte. It is there. 4 cannot be divided by 7. This is true. So I take into account the p byte. It is there. 4 is even. This is true. So I take into account the p byte. It is there. And 4 is odd. This is false. So I do not take into account intermediate. So we will do that 5,000 times from iteration 0 to iteration 4,999. Okay, we don't have time to finish that, so I will come back on it on Thursday. On Thursday, I will continue from the loop. So we will see that again, and we will finish the exercise. So please look at this video, look at the PDF file that you have in Canvas, and try to understand what is missing. Okay, because this is the way that Linux store your password. So as you can see, it's go through a long process before it find a way that is going to store it in a computer. Okay, I'm going to finish here for today. I see you on Thursday.